Hey folks, welcome to my channel. And today we were going to solve this problem, ADA merge sorted array. What is this problem talking about is we'll be giving like two integer arrays, numbers 1 and numbers 2. Both of them are already in a sorted order. It's a non-decreasing order, meaning that, like, for example, we have the number 1, 2, 3, they're already in a ascending order, and the numbers 2 is 2, 5, 6, 6. Each the number will be greater than the previous one. All right, and then what we need to do is we need to merge both of this array, and then we will then get a sorted array. So what we like, for example, like the sorted one is 1, 2, 3, 1, 2, 2, 3, 5, 6, right? This will be the sorted array, like when we merge both of them. And there is also a requirement is the sorted array should not be returned by the function, but instead be stored inside the array numbers 1. What does that mean? It means that we cannot create a new array. The result should be also will be replaced for the original numbers 1, like this. There will be a new array and we won't see the original one, the numbers 1, and this is the result. So this is its requirements, and that's why we will see there's so many 0 there, because the numbers 1 is already has the length of the m plus n, and where the first m elements denote the elements that should be merged. Okay, so here are some examples, like yeah, this is what I list here. Numbers 1 and numbers 2, both of them each of them will have like 3 numbers. And example 2 is like the numbers 1 only have 1 number, and the numbers 2 doesn't have any one, so it would just directly returns the number ones. Yeah, and the example 3 is the numbers 1 has 0 number, but the numbers 2 have 1 number. All right, and now let's take a look at this standard one first. What we will do is like there's no doubt that we love to have a pointer to point to the each of the array, and then compare each of the number in array and try to replace one. But if we are assume that, like, if we have the pointers at the beginning of the array, for example this one, and now we see the 2 is greater than 1, we definitely like continue to have the 1 here and move the pointer to the next one, and then yeah, continue to move, and now 2 is smaller than 3. We love to have 2 here now, but the point is the 3 will be disappear, right? We don't have a mechanism to store this 3, so it means that it's not an ideal way to compare the array from the beginning, right? And probably we can have the compare the array at the end of the array, so that because there's nothing to point it to nothing in the numbers 1's array, even though we have already replaced that numbers, putting a new number here, it doesn't have any impact on the original array. So this is what I'm gonna do, like to initialize the pointers at the end of the array, right? So show like the pointer ones, of course, or maybe we just say pointer 1 at the end of the array. Okay, that's not the idea, because when we are comparing this, that definitely that like the numbers, the number in the numbers 2 is always greater than the numbers 1. This is what I don't want to do. I just want to compare the numbers at the end of the array. So it means that we also have like the another pointers help us to point to a place that here you can put the number, right? Usually we start at the end of the array. Okay, so now we will have a new pointer here. So this pointer will say that, okay, I am where you put this array. Alright, this is not the ideal way to show, okay. Okay, just remember it. This is the pointer I. And now, yeah, so I will have like an I pointer equals to, this is the end of the array. Because the length of the number ones is m plus n, so the end of the array should be -1. So we'll have a pointer starting from here, meaning that where we put the number, right? And also the pointer 1 and pointer 2 is pointed to each numbers. For example, this will be pointer 1, and this will be pointer 2. Yeah. Alright. The pointer 1 will be the end of the numbers. I mean point to the last number. So it means the index will be m-1, and p2 it will be n-1 as well. Now we start to compare these numbers, right? The p1 and p2. And as we all know, like there will be some conditions will be like, first is if the p1 number is greater or equal, doesn't matter. The number 2's number, what we gonna do, this is the first case. And the second case is, what if the pointer 1's number is smaller than the pointer 2's numbers, right? What we gonna do for this case? There are two cases. Yeah, and this is what we're gonna do. And when we are doing this, it means that we are deciding to traverse the whole array. So yeah, when we initialize the pointers, we can just loop the array. But then we will have a question is when to stop, right? Now let's just mimic this situation first. Now if the pointer's 1 number is greater than the point 2, no, now it's not the case. Now we can find that the pointer 2's number is greater than the pointer's 1's number is the case 2. So what we're gonna do, then we will definitely like the I pointer's numbers well equals to the pointer 2's numbers. This is the result. We can just delete it correctly so that it won't distract us. Now we know that the number 6 will be replaced here, and then after we have this result, we can move to the next position. So the next step is I will move to the left, right? And as also now they already have a number, we can also move the I pointer to the next position, right? And also, okay, this is the P2 first. And I also move to the left. And then 5 is still greater than 3. We continue to do this. And we also have 5 here, right? And now the P1 is finally greater than the P2. So it means that here, the P1 number is greater than P2. Then we will have numbers, the I pointers numbers will be replaced with the P1's number. And also we can P1 move to left, and I move to left too, right? And now we have number 3 here. And now they are equal, so the equal means still meets the first condition. So we can move the P1 to the left, oh wait, there's a problem. If the P1 number is greater or equal, so for the first, like, if they are equals, so for this one, I will be replaced with 2. Okay, it's okay, it's totally fine. Numbers will equals to P1s, and then P1 move to 1, and also I move 1. And now P2 is greater than the P1. So, yeah, we will have 2 again. And the P2 move to here. And this pointer, I pointer, will move to here, point the same way. So here now we can see that we can stop. So also this answer will already come out like we can stop, loop the rate until P2 less than 0, or probably in another condition is if this is not this example, like the P1 already moved to 0, we also can stop, because if the pointer is -1 or -2, we cannot get the number from the array, because number -2 or numbers -1, I mean the index, means nothing. It doesn't make sense. The program language will throw some exception. So both either of this pointer less than 0, we cannot continue to do that. And now the numbers 1 is already what we want to got, even though we don't have to move the pointer 1, it already be like 1, 2, 2, 3, 5, 6, right? And this is what we all want to go. And now here's another problem, like for the example 2 or 3. What if the pointers 2 is still like be here, for example, right? Like if we are not using the number like 2, maybe probably 1 or something, and this will be 2, right? It means that all the 2's comes from the numbers 1, and the we still have 1 letters in the numbers 2, haven't like put it into the numbers 1. So after all this loop, we will continue to check, is there any numbers left in the numbers 2? The number left in the numbers 2. If there is, we have to continue to replace the rest of the put the rest of the numbers in the numbers 2 to the numbers 3. Right, if yes, continue to put the numbers, put the rest of the numbers in numbers 2 to numbers 1. This is what we are gonna do. And now let's bring these ideas to the coding part. Okay, so now we already have this idea. Let's do coding with this the pseudocode on the right side. And we first initialize the pointers. This is the pointer where we start to point the number, put the numbers. And also we have the P1 equals 2 minus 1, and P2 equals 2 and minus 1. And we can say we're looping until a is smaller than 1. So it means that we have to keep all the pointers pointers are greater than 0. So while like P1 greater than 0 and P2 greater than 0, what we do is we start to compare the numbers. 1 P1 is greater equals to numbers 2 P2. If yes, we have to replace P1. Oh, I think, yeah, numbers 1 I equals to numbers 1 P1. After that, both of these pointers have to move to the left. It means minus 1. Else is definitely like the rest of them will be the P1 numbers are smaller than the P2 number. So then numbers 1 I equals to numbers 2. Yeah, I always miss S here. P2. And after this, we will move the pointers as well. And then we are continue to check if there are any numbers left in the numbers 2. While P2 is still greater than 0. Right. And the numbers 1 continue to numbers 2, P2. we also need to move the pointer to left. So now let's run it. Numbers, okay, missed it. Looks good. Right, okay, let's submit it. So all the cases already accepted. So hope this video help you to understand like how we solve this kind of problem. And actually it's like a part of the merge sort. So if you have time, you can also learn more about merge sort to see how we sort it. I mean split the array into two parts, and then each of the parts already sorted, and then we continue to merge. So this is what this kind of problem want to practice, like how we merge two sorted array. So it's a part of the merge sort algorithm. So thanks for watching.